Hello, everyone. It's my pleasure to introduce Maxence. Maxence is a scientist at swMATH, which is an information service for mathematical software. He's a doctoral researcher since July of 2022. His research covers open source scientific software and related AI topics, including software recommendation, software citation, software entity recognition, and neural code search. Maxence will be talking about swMATH with us today. A framework for discovering mathematical software within large open source repository collections. Please take it away, Maxence.
Okay, thank you so much, Alan. Hello, everyone. Welcome in this presentation. The idea of this presentation is to show you uh, what is SVMAT and where is going SVMAT. So SVMAT is for now uh, one of the leading catalog for mathematical software. We harvest and index more than 42,000 software in the domain of mathematics, and also we index and we collect the mention of software in mathematical research articles. In this regard, I'm working also with Software Heritage as an ambassador as well to take care of this software, to archive the source code, to help the citation of them, to provide the source code with proper identifiers, and together we are, I think, trying to build a more sustainable ecosystem. So, as you might have just recently, I think, Ellen, we can go to the next slide. Great. So, as the last update for SUMAT, SUMAT has been recently funded by the German Research Foundation. So the point of this grant is to support a new project for SUMAT, is to build a discovery feature for SUMAT, because now SUMAT, what it is a catalog of metadata of mathematical software, and the idea is to help mathematicians who are using SUMAT to follow up on the state of the art of mathematical software, to find a new source code, and to have also a feature for like recommender system for mathematical source code. So the idea first is there is three steps in this project. The first step of the work package one of this project is to identify identify new software that perhaps we don't know in SVMAT. And second, to integrate this new software and to build a recommender system to help mathematicians to identify potential related software together. Like they're looking for specific functionalities, and they can identify new software with similar functionalities. And the third part of this project is to deploy this system and to evaluate it. We can go to the next slide. So that's a bit the idea of what I was saying when I was speaking about the recommender system for source code dedicated to mathematical source code. Typically here we have two similar functionalities in the domain of mathematics, in the subdomain of topology. These two functionalities implemented in different languages, implemented in different software, are mostly implementing the same thing. The idea is that sometimes you want to have a state of the art or an overview of many functionalities in a subdomain of mathematics, and you want to be able to compare them, to compare the implementation, and to be able potentially to reuse it. That's the idea of it. When you have looked to SVMAT today, this is a this is a top view. We have a view of the functionality software, but we don't go so much in the detail of source code. And the idea of this project is to go a step further, to have a look into the source code, to help the user to browse the source code itself and to discover new functionalities. We can go to the next slide. Perhaps the connection is not the best. I can see the chat. But anyway, I will do my best on that. Um, so that's a bit the detail of what I was saying on regarding the work packages. So first we want to find new software, but where to find this software? That's complicated, and this is why we are. I mean, this is why we are using software heritage. This is why we are leveraging software heritage, is to discover software we could potentially not have found in mathematical research article, or software that could not be famous in the math community. And thanks to software heritage, we can access to the to the whole world of software, and I think this is a very good place to have a software. So that's the work package one I will a bit later explain on, and the work package 2 and 3 that I just talked about before, about building a recommender system specifically for source code and after to evaluate it. I think we can go to the next slide, Alan. So that's the idea. So how we can find software, how we can find software in software heritage. What we were trying to do this last month, that's experimental, I have to say. This is what we're doing in the context of the work package 1 and what I want to show you today. We are using ontologies, specific ontologies of the domain of mathematics. One is very famous, is classification. It gives you a very rich ontology with very rich vocabulary, very rich terms associated to the domain of mathematics. And so, thanks to that, we could build a very interesting textual representation of mathematical languages. We have used this MSC, this mathematics subject classification, identify software that are in the area of analysis, geometry, of combinatories, etc. And so that's the idea of using ontologies to find new keywords that perhaps we don't know and to identify a new software also don't time. But I will explain you better with the next slide. And so the idea with what I was just saying before about using ontologies, it was to try to match topics we can have in GitHub. For that, some software that we can find in software heritage, but for the one we already know what is the topic we can find, like the topic we can find in GitHub, and thanks to it we could compare thanks to simple similarities the mathematics vocabulary, the mathematics term we have in the domain of math, and some topics we can find in software we never see before, we never saw before. And thanks to that, we could try to identify and attribute the term of mathematical software to some software we never saw before. And in this possibly identify a bit less than 30,000 software. That's a target, if I can say, of what we could find among GitHub software that are registered in software heritage. This is for now a minimal target, if I can say, because we would like to harvest all the sources. But this is the first work we have implemented for now. Thanks to this software, we have that's the second part. With this software, after we try to evaluate them, I think we can go to the next slide. Yeah, we have tried after identifying this software, this candidate, if I can say, the software candidate, to evaluate them with LLM, with asking LLM to use things by reading this README, by reading the topics of the software. Can you automatically consider that if it is a software relevant of the domain of mathematics or not? And so for most of them, for 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 for, for most of them, sorry, for most of them, we could consider that this software were mathematical software. And also behind that, we have started recently to have a detail, to have a review of this software regarding the source code, regarding also the README. If yes or not, this is mathematical software. If yes or not, we consider that this software are not just about math, but also about research in math. Typically, it can be software that could be written by PhD students in during an internship, or cite the source code associated with an article. So we are trying to process this work now. We can go to the next slide. Is for the next steps regarding this work. We have a lot of debate. I mean, essentially me, I have debate with myself. Should integrated in swMATH or not? Should it be considered as purely research software or software that should be added in a new registry? So we have new questions regarding that for the work package one of our project. And also, should we extend this work to other sources like GitLab, for instance? So that's so this is the question, the kind of question we have. If we integrate this software in swMATH, we should perhaps give them or attribute them some MSc codes, codes associated with the mathematics subject classification I was talking at the beginning. So we have all this debate regarding the work package one. And then after, when we integrate this software before, be to integrate them we need to reuse them for the work package 2 and the work package 3 by helping the mathematician to discover new source code, perhaps the source code they could not see before, and after to evaluate them, to evaluate the quality of them in a recommender system. So regarding the next direction of this work, I've clearly focused on software heritage, on GitHub, perhaps on GitLab. We often think with some colleagues working on sister projects in Germany. We consider perhaps having a look to data, and especially within functions. There are some things that could be possibly integrated. As there is software we don't know that could be findable there. Well, there is also the CRAN repository. Also, we could expect finding a lot of R packages for mathematics. So yes, this is how it's going this project for now. And for now, it is more at a stage that is quite experimental. We are trying to implement techniques, and we could already find things that are quite interesting to us now. Give you some ideas for the future. I mean, this is the direction we are taking for now, and I'm very open to and very happy to have some questions from you. Thank you.
Great, thank you, Maxence. There was a bit of breakup sometimes in the audio, but I think hopefully people could read between the lines. It looks like Hervé has a question to start with, and
Yeah.
then Daniel.
Very interesting presentation, Maxence. I think I understood most of it. The one thing I just wanted to mention, because it's really close to one of the projects I'm working on currently, is that we're with Elixir, we have an ongoing collaboration with bioconductor community to integrate their software into our registries. And obviously this whole work where I'm really open to sharing and discussing on the topic if you can maybe reuse some of it or not.
Yeah, That's very interesting you talk about it because that's part of a research article I've just been working on that is on the review process related to this work. I mean, that's a general view of the research we're doing now, currently on process of review. I'm also approaching the topic of biology. So perhaps we have also with the EDAM ontology. I think you certainly know the EDAM ontology.
Yeah,
So and we evaluated against biotools. And so I think I have results that perhaps could be interesting to you. I think I mean I have to say my results on the approach we implemented were better on biology than for mathematics. So I think we have results that could be
yes.
open. I mean when I come back from because now I'm on vacation now, uh, but I come back next week, so perhaps we could organize a meeting if you want, and I can share with you some of the results I have, and probably can be interesting for you. So I would be just happy to help on that. Yeah, sure.
Absolutely. Feel free to send me an
Yeah.
email whenever.
Okay. Okay.
Daniel?
Thank you, Maxence. So I have a few questions and then also, well, a question or reflection. The one one question that I have regarding your presentation is that you had that your approach was competitive with regarding an approach based on embeddings, right? And my question is an embedding of what exactly? Are you embedding the readmes? Are you embedding the functions? Are you embedding the whole code?
That's right. We were embedding we were yes regarding the we are embedding the embedding were against the sorry the keyword, yeah, it was it. So regarding the ontologies we were generating some a few list of terms with some semantic representation, and the idea was to compare the text. I mean the how can we say that? Yes, sorry, the representation of the ontologies with um, with um, with the topics we can have in GitHub. And the idea is that for that we're simply using embedding, baseline embedding on the GitHub topics and computing similarities and try and using kind of heuristic to conserve a certain software regarding the level of similarity. The other approach we have
Mhm.
implemented, the main one, was based on contrastive learning, and this one was a bit different in the sense that we were trying to have a kind of kernel of bad software and to try to find software that are a bit aware of this one, to try to cluster them. So the approach was a bit different, and this is
Mhm.
what again the one we've been evaluating. Yeah.
Okay. Well, one of the things that I mentioned is just because just calculating maybe embeddings based on the topics of GitHub, a lot of the topics of GitHubs are not very good because sometimes people just say, yeah, this is like a code repository and they put code as a topic, or they put like API, and you're like, okay, well, but it's not a topic, no? It's just things that are in there. So the data
Yes.
quality is a problem. Okay, moving on. Um, it so let me see how can I phrase it. So it looks like one of the use cases that you have is that you want to find well relevant functions for a particular function that you are interested in. So the question is, if I have now generative AI that generates the function I'm interested in, why would I be still be interested in finding um, functions that are similar to the one I just saw? So I was wondering if, well, basically, how does this work in that scenario? Or is it to compare, is it
Because
approaches for building benchmarks in which then I would understand very much this use case, right?
um, because sometimes you want to find software that you are sure has been implemented by someone else before. Typically, when you want to implement a very complex functionalities, I think, I don't know, in some subdomain of mathematics, and there is a few researchers who have been trying to implement this. I think there is kind of a high risk of having improvisation, if I can say, sometimes from AI. And you want to be sure to have a qualitative writing of the source code, and you want to have an overview of what exists and how it should look like, because sometimes you want to implement a new thing, but you don't know if it's looking
Right. Sorry,
especially if you
you
have,
broke up. Okay.
I mean, yeah, and so to me, we still, I mean, even at the edge of AI, where
I'm
reformulate
sorry,
the
you're
source code,
breaking up,
something
Maxence.
implemented in C++, you want to okay. Sorry, yeah, I can't do a lot for that. But I think we still want to read source code. We still want to find source code. And for this reason, we still want to be able to compare source code and to find new ones. I think the age of generative AI is not changing anything on that. We still want to be able to compare functionalities on the ways they've been written, on the ways they've been implemented, especially in research. That's my
Right,
that's my
but
strong opinion.
my point here is that I think you're mixing granularities, right? Because you are talking at some point at the level of a software tool, in which I think you're right. I mean, at the software tool, this is not yet trustable, right? Because software tools are complicated and have many different sub-functionalities. But then
Hmm.
the example that you showed was at the level of a function. And at the level of a function, I think that most people will just go and ask the generative AI to create a short function to do whatever, no? So at the level of scripting, more or less, you can trust it because you can also test it and it will fail or not, no? Then
Yeah,
if the use case is benchmarking, then you've got a point, no? You need to find functions in different maybe languages because you want to compare their performance. That's a perfectly valid use case. So I just want to understand. Well, that's it. Maybe it's a way in how it was phrased. That's fine. Um, but I think I see it now more clearly.
okay.
And the final one is a comment that maybe Peter Tuven, your ears start ringing because I remember that at the previous Psychodes workshop, uh, he came up with a suggestion that wasn't followed up, but that was on that we need to annotate the functionality associated with software tools, right? And
Yes.
This is basically what Maxence is trying to do, but one of the problems is that we don't have that metadata, no?
Hmm. Yeah, it's not standardized. Yeah.
So
Yeah.
maybe now there is a chance to come back to this idea and try to push it forward in a future version of Code Meta, that we include some sort of registry of the main functionalities included in a software package, right?
Yeah,
I mean,
especially.
yeah, Alan.
Oh, I was just going to say, especially in this age of Gen AI, where it seems like we're moving towards a system where we document what the software is for AI agents as well as ourselves, our future selves, but doing it and writing these markdown documents that describe here are the entry points. This is what this software is about. Here are the relations. So you can properly build this graph at different scales, as Daniel was talking about, right? Because sometimes you may want to find a function that's very well tested. So you want to see all the unit tests for it. You want to see the performance characteristics of the code, the trade-offs perhaps in the different implementations of them, whether it's in Python or Julia or Rust. So, and then the implementation details are managed by our LLM overlords as our own critical thinking faculties atrophy. Peter.
Yeah, so that made me wonder about, and I've been wondering about that actually the last few days with all of that AI. If you know all of your codes, this goes back to the time when we had Google Code, I believe it was called, which I really liked at the time, but it has disappeared. But now with everything being available, and if you ingest it, you might say we don't even need these things anymore. You can automatically extract what you want from an LLM if it's been done properly. So that made me wonder, do we even need something like ASCL or swMATH? It's all under our fingers.
No, AI actually generally does not do a very good job, in my experience anyway, of describing software. So I have been experimenting with AI with a couple of different ones to try to write descriptions, for example, for codes that I'm adding to ASCL because I'm not an astronomer and me writing these things, which I've been doing for years now, but I'd like to find an easier way to do it because that's a task I just don't like doing. So I've been experimenting with AI and I ask it, using what's in this GitHub repo. Here's the GitHub repo for it. Please write a description of what this code does. And it's surprisingly bad sometimes. I AI hallucinates. So, and it will
Well,
take,
at this stage, Alice, I'm playing the devil's advocate, of course, here, but
yeah,
in far future, maybe we can go in that direction. And to get
it
back
would,
to Daniel's comment about the code, if we
yeah.
have in our metadata a descriptor in
Mm,
which way these things are documented, is it Doxygen, is it Python standard underscore underscore docs? Um, that could already help digesting them and making good trees of information.
yeah, that's true. If you've got good metadata already,
Yeah,
um,
no, I mean there's a
it,
metadata tag that tells you in which way things are documented.
yeah.
Then you can scrape that and ingest that.
Yeah,
Now, if
in the
only
end,
people,
sorry, Alice, go ahead.
no, I was just going to say, now if people would only document stuff and add that metadata, you know?
Oh,
So,
if you build something, it will come. Isn't that the expression?
yeah. Go ahead, Daniel.
Well, yeah, the problem with language is that it's inherently ambiguous, no? And I think that many of the problems on data integration that we face as humans are will be faced by agents. In the end, vocabularies are not just things to make things machine readable. They are agreements between people on how they are gonna name things, right? And the important thing is the agreement. The technology that you use to implement it, whether it's a markdown file or whether it's a JSON file or a OWL file, I think that's becoming less important because of the way these agents interact, no? But in any case, if you think of the agents just as people, if you have a registry of, hey, what are the common functions of this supported by this software that is easy to ingest, it is useful also as a human. I mean, we don't do it probably because we don't have the capability of going all over the whole repos and document everything, no? But it may be something like the new formats that people are investing on for translating readmes into more parsable for machines or model context protocol and stuff. I think these are ways of making these things more digestible. So this would be another one. Anyway, food for thought, and maybe we can add a new property to code meta that suddenly gets more adoption. I don't know.
Yeah, or just have a clear guidance for if you want to include this, just do it this way for now so people can standardize it before there's formal support. Is there a properties, for instance, in code meta where you could point to this? I mean, it might just be a link to a file in the like a context.md or agents.md or something. I don't really like the agents.md because I want this to be, as you say, like human. It should be for people, and the agents are also able to consume it
Well,
effectively as well.
agents means also human agents. An agent can be a human. There is nothing
That's
against it,
that's
right?
that's fair, I guess. I do like this. If people go check out this compound engineering manifesto that I put in the chat, I think it is an interesting um set of or an interesting design philosophy. It really does touch on what we want, right? Which is to support maintainable, reproducible software that's comprehensible now and into the future. You want it within the scope of what the software was developed for. So. Are there any other questions? If not, I'll stop the recording. Thank you, Maxence.